Hello everyone, my name is Hassan Adamu. I'm going to present our research paper titled Text Analytics on Twitter Text-Based Public Sentiment for COVID-19 Vaccine, a Machine Learning Approach. Here are the authors list. The first author, I myself. Then my co-authors are Matt, Dr. Gang, and Dr. Nurhana Samsuddin. Here is the presentation outline. I have about 6 items to present today. The first item is introduction. Second, mapping research question and objectives. Methodology, experimental analysis and discussion, conclusion and recommendations, then references. Let's begin with the introduction. What is text analytics? The concept of text analytics is nothing rather than to mine a text data from internet. This internet, be it a social media or other platforms. So if you look at this chart, there are about 4.66 billion active internet users around the world. And also, there are about 4.28 unique mobile internet users. And also, there are about 4.14 billion active social media users. And lastly, we have about 4.08 active mobile social media users around the globe. This data is fetched from Statista Infographic, April 2020. If you look at the total number of active social media users around the world, there are about 4.14 billion. So you can imagine the kind of the text or the kind of the data that people around the globe are depositing every second. So in this research, we choose Twitter as an object or as a platform for us to mine our text data. Then the next thing is sentiment analysis. So in this research, we use 3 sentiment analysis classes to drive or to get the insight or the opinion or the sentiment of the people regarding what? Regarding COVID-19 vaccine. So in this research, we use 3 most popular sentiment analysis classes, which is positive, neutral, and negative, to classify our data. So how are we going to classify our data? We are going to apply 2 machine learning algorithms, which is machine support vector machine and k-nearest neighbor, to evaluate and classify the opinion of the people regarding this COVID-19 vaccine. What are the research questions in this research? So we have about 2 research questions. Number 1 research is how can pre-processing of Twitter data and machine learning algorithms can help in detecting public emotions or public sentiment regarding the COVID-19 vaccine. So these 2 research objectives answered will try or will address this research question. So number 1 is to collect the Twitter data, which will be on the public sentiment on the COVID-19 vaccine. And after collecting the data, we are going to clean the data set by applying different pre-processing techniques such as stopwatch removal, hashtag removal, lemmatization, and etc. So I believe these research objectives can be mapped with this research question. And the research question number 2 is the performance variation of the machine learning algorithms. Like I mentioned, we are going to apply 2 machine learning algorithms to evaluate or to classify the opinion of people regarding COVID-19 vaccine. So this is SBM and KNN are going to be applied. So, and we are going to compare their performance, the variation of their performance based on the classification or evaluation of the opinion of the people or sentiment of the people around the globe, that is regarding the COVID-19 vaccine. So this research is nothing but to see the level of the opinion of the people regarding the COVID-19 vaccines. Do they really want the vaccine or do they want? So this is the methodology. This is a popular data mining technique that is being used to mine a data up to the evaluation of the data. So we apply this, the most common or the most popular technique, that is data mining technique, which is CRISP-DM, cross-industry process for data mining. You can see the CRISP-DM has 6 stages, right from the business understanding, that is the kind of the problem that you want to address, the data understanding after collecting the data, how you are going to clean the data, prepare the data, model the data, and evaluate the data. Then after evaluating the data, you see the level of the performance of the machine learning algorithms. Then you deploy the model. So the Twitter API that we use in this research is TweePy. And also, of course, this research is qualitative research because it's social media data. And also, the programming language that we use in this research is Python. And also, the Python libraries that has been applied while evaluating this or experimenting this research is NLTK and scikit-learn. This is the continuation of the methodology. This is the sample of the data collected, and you can see the raw Twitter data that we have collected is about 7,608. So you can see the kind of the data is somehow noisy, so we have to prepare the data before we can pass it into the machine learning algorithms for classification and evaluation. So this is the description of the data sets. Of course, the data set was multivariate and there is no any missing value, and after pre-processing the data, we get a final complete data set of 5,200, and also the number of the attribute is 3, and also the data type of the data, that is the data type is text, because we are dealing only with the text data. And also this is the model, the workflow of the model of the experimentation. So from the data set, we apply the pre-processing techniques. After pre-processing techniques, we apply feature engineering, which we use terms frequency, inverse document frequency, that is TF, IDF. And after that, we split the data into 2, that is 70% for training and 30% for testing. Then after that, our machine learning algorithm, 2 of the machine learning algorithm, we apply and evaluate the data. So this is the analysis and the discussion. So this result or this chart clearly shows that the sentiment analysis class distribution, that is positive, neutral, and negative. So the distribution was made based on the automatic detecting while pre-processing the data. Then we apply one of the technique that automatically detects all the text, that is the data set, and out of the data set we have 31% of the positive sentiment, and also we have 47% neutral and 22% negative. So this data, after driving this sentiment classes, then we are going to pass it into the machine learning algorithm. But you can see that the data is not balanced, so we can see in the next slide that we apply a technique that can help us to balance the data before passing it to the machine learning algorithm. This is nothing but the word cloud. This is and if you already know that the word cloud will try to depict pictorially the most frequent text. So we divided them into 3, which is the sentiment analysis classes: positive, neutral, and negative. So for the positive part, you can see that effective, approve is a positive comment. So these are the most frequent text that appeared. And also for the neutral, you can see today, vaccination, and you can see for the negative, emergency, vaccine, and also death is also a negative comment. So these results or these sentiment classes, the distribution, the labeling, where we apply smart technique. You know, the data set was unbalanced, so we apply smart technique, that is synthetic minority oversampling technique, to help us balance the data. And the evaluation metrics that we use in this research is accuracy metrics, because sometimes most of the unbalanced data we apply either ROC or accuracy metrics, so we just care about the accuracy of the model. So after applying this smart technique, we pass our machine learning algorithm, and this is the result that we obtain based on the accuracy of the model. So SBM, as you can see, the result shows that SBM is 88%, and Kenya's neighbor is 78%. So based on this, if you want to compare them, support vector machine surpasses the result of the KNN. So support vector machine is better than the KNN in terms of this research. So the last slide is a conclusion and recommendation. So some of the conclusion and recommendation in this research is: number one, Twitter data and machine learning techniques can be leveraged to analyze emerging public debates and feelings, especially regarding this COVID-19 vaccine. Then also the capability to have real-time monitoring of public discussion and concerns for public health and emergency planning. Also, it will assist government and authorities in decision making regarding COVID-19 vaccine. Example, number of vaccine to produce or purchase. And also have the opportunity to educate people to increase the vaccine uptake. And also, machine learning algorithms requires more data. So in next research, we can collect more data from different platforms, social media platforms like Facebook, Instagram, and WhatsApp, and we can collect more data so that the machine learning algorithm can their performance can be improved. This is the reference, and thank you for listening.